Hey everybody, so in this video we're going to be talking about multiple ways that we can solve quadratics. So our first way of doing so is by graphing. So here they have given us this equation of a quadratic and they've given it to us in standard form. So anytime you're graphing in standard form, the first thing you want to do is identify your axis of symmetry. And we do that by using this formula, x equals negative b over 2a. So this is going to give us the center of our quadratic. So remember that your first term, this is your a, b, and c. And the values for a, b, and c are the coefficients. We are not referring to the variables. So here, my axis of symmetry is going to be negative 2 over 2 times 1. So here, negative 2 divided by 2 is just going to be negative 1. Now, negative 1 is the center of my graph. Now, I want to know the y value. Where on this negative 1x value am I going to have my vertex? So I'll take negative 1 and I'll plug it into this equation here. So that gives me negative 1 quantity squared plus 2 times negative 1 minus 3. So here, negative 1 squared is 1 minus 2 minus 3. 1 minus 2 is negative 1 minus 3 is negative 4. So my axis of symmetry is negative 1, negative 4. So what I'm going to do is I'm going to come over to my graph, negative 1, and go down 4. 1, 2, 3, 4, and put my dot. So my quadratic is either going to open down or it is going to open up. And the easiest way to determine that is just to plug in values into my quadratic. So I started here at negative 1. Let's plug in a value to the right. 0. 0 squared is 0, plus 2 times 0 is 0, minus 3 is negative 3. So 0, 1, 2, 3, negative 3. Now, what's nice about a quadratic is whatever the y value is 1 to the right, that's the same y value if I go 1 to the left, because they're completely symmetrical. So now I can plug in positive 1. So now I have 1 plus 2, that's 3. 3 minus 3 is 0. And if that's the y value 2 places to the right, that's going to be the y value 2 places to the left. And the whole idea of solving a quadratic by graphing is to see where it crosses the x-axis. So here it looks as though it crosses the x-axis at negative 3 and positive 1. So here, my solutions would be negative 3 and positive 1. These would be the solutions to this quadratic. All right, now we'll do the same thing with this quadratic here. So if you would like, go ahead and pause the video and you try this one on your own. We're going to do the same process. We're going to find the axis of symmetry and plug it in. This way we can identify our vertex. And then we're going to plot values 1 to the right, 1 to the left, 2 to the right, 2 to the left. So here for my axis of symmetry, I have x is negative b. So that's going to be negative b, negative 10, all over 2a, 2 times negative 1. So here, this is positive 10 over negative 2. Well, positive 10 over negative 2 gives me a negative 5. So my axis of symmetry is going to be here at negative 5. I will take this, plug it in order to get my y value. So this is negative 5 squared minus 10 times negative 5 minus 25. So this is 25 times that negative 1. This is negative 25 plus, because the negative 10 and the negative 5 give me 50, and then minus 25. So here I have negative 25 plus 50. That's 25 minus 25 is 0. So here what we have is we have a vertex at negative 5, 0. So we're going to plot that. So let me go ahead and erase this right here. And we'll plot our vertex at negative 5, 0. Now, one thing you got to know, if the vertex is on the x-axis, this is only going to have one solution. Because with quadratics, you can have two solutions. See how it crosses here in two places. You can have one solution. That's when your vertex is on the x-axis. Or you can have no solution. So the graph would never cross the x-axis. So here, this is either going to open up or it's going to open down. Here, being precise with our graph, we don't really have to do because we already know the solution. We know the solution is x equals -5. Right? Because the vertex is on the x-axis. That's the solution. And because the leading coefficient is negative, we know this is going to open down. So here, this would just be a rough sketch so you can see it, but we know the solution is going to be -5. So that's how you solve by graphing. Let's take a look at a few other examples, and we're just doing a quick refresh from Algebra 1. So here, we're going to solve by taking the greatest common factor. So here with 12k minus 18, I'm going to think, what's the largest number that can go into 12 and 18? Okay, and that is going to be 6. Now, one thing that a lot of people seem to misunderstand, factoring is synonymous with division. They're the same thing. If you factor out a 6, you divide everything by 6. So we can even illustrate that here. So let's come down and let's just divide everything by 6. And that will give you the remaining factors. So 12k divided by 6, this is going to be 2k. 18 divided by 6 is going to give me 3. This cannot factor any further, so here I am done. All right, let's look at this one. What's the largest number that can go into 14, -35, and -7? 7. Now, you can pull out a -7 or a +7. It really doesn't matter. Here, we can just pull out a +7. And now we're going to look at the variables. So with your variables, you have to pull out the smallest exponent. So I'm going to look m to the 6th, m third, m squared. I can only factor out m squared. Now remember, factoring is synonymous with division. So just so we have a visual, I'm coming through and I am dividing every term by 7m squared. This gives me the remaining factor. So 14 divided by 7, this gives me 2. Remember that when you're dividing with powers, you subtract. So 6 divided by 2, or excuse me, 6 minus 2 is going to be 4. There we go. -35 divided by 7 is -5. 3 minus 2 is 1. 7m squared over 7m squared is 1. And here I have factored out the greatest common factor, resulting with this polynomial. All right, last one. So here I have 3, 5, 8. What's the largest number that can go into all three of those? There isn't one. I can't factor out a number that can go into 3, 5, and 8. So we're going to leave the numbers alone. I can only factor out the variables. Remember, with variables, you can only factor out the smallest exponent. A squared, A. So here I'm only going to be able to factor out an A. What's the smallest B? B. So I can only factor out a B. Remember that factoring is the same thing as division. Now, I keep stressing that because this is going to get a little bit more advanced, and you need to be thinking in your head. Anytime I'm talking about factors, I am referencing division because that's going to show up later in Algebra 2 when we say things like long division. Why would we need to use division to come up with the factors? Why are factors nice? Because I can set them equal to 0 and find the x-intercepts. Oh, look at there. It's one big vertical train of thought. So here, these a's are going to go away. 2 minus 1 is 1. So here I am left with 3b. 2 minus 1 is going to give me 1. These b's are going to go away. So I'm going to have minus 5a. These ABs, well, excuse this A and this A, going to cancel to 1. This B, going to reduce to 1. So I'm left with 8. And here I have factored out the greatest common factor. Okay, other ways to solve when factoring. You have when A is equal to 1. So these are the nice and easy ones. So with these are going to be the type where you are going to look at the third term and the second term. Okay, now with the third term, 45, what we're doing is we're saying, okay, what numbers can multiply to give me 45? And when I add them or I combine them, I get positive 14. So let's think about the factors of 45. There's 1 in 45. Can I combine these two in any way to get positive 14? You cannot. All right, let's go to the next. Will 2 go into that? No. Will 3 go into that? Yes. So 3 and 15. Can I combine 3 and 15 in any way to get 14? No, I cannot. All right, let's go further. 4 will not go into 45. 5 will. 5 and 9. Can I combine those in any way to get 14? Yes, I can. If you add 5 and 9, you will get 14. Oh, look there. So I am going to use, these are going to be my factors. I have x plus 5 and x plus 9. So that's going to be the train of thought. You're always looking at the multiples of the last term. Okay? So 36, multiples of 36 that I can use and combine and get 12. That's going to be 6. So here I could say that this is going to be a plus 6 times a plus 6. Now, this is going to show up quite a bit, perfect squares throughout this unit. So one way that you want to rewrite this is a plus 6 quantity squared. This is going to be convenient when you start doing things like completing the square, which I know that we saw in Algebra 1, but this is the way that we're going to write this. Okay, lastly, I have 2k squared minus 16k minus 40. Remember, anytime we are factoring, remember what we did here, the greatest common factor? You can kind of think of the greatest common factor as step always. It's not even step 1. It is step always. We are always going to check for the greatest common factor. Here, we didn't have to do that because the leading coefficient was 1. But anytime the leading coefficient is not 1, you are required to check for the greatest common factor. So here, before I do anything, I am going to factor out a 2. And what does factoring mean? What am I doing when I'm factoring? I'm dividing. Ah, look at y'all. So smart. So here, I'm going to factor out or divide everything by 2. So now what I have is k squared minus 8k minus 20. Now I have this quadratic that I'm going to factor. Look at the last term, 20. What factors of 20 can I combine and get negative 8? How about 10 and 2? So here we have 2 times a 10, k, and a 2. Now, I left the signs blank intentionally. Think about this. I need to multiply these two numbers together and get negative 20. So that means one of these numbers has to be negative. So one has to be negative and one has to be positive. Okay, so which one? Well, let's look at this middle term. When I combine these two numbers, I should get negative 8. So how am I going to add these numbers and get negative 8? I'm going to make the 10 negative and the 2 positive. Negative 10 plus 2 is negative 8. Negative 10 times 2 is negative 20. Oh, it works. And that's it. That's all you're going to do. All right. Now, what happens when a is not equal to 1? This is the one that nobody seems to like. And I don't know why. It's just as easy. Now, here, step always is look for the greatest common factor. Is there a number I can factor out that would go into 2, 15, or 18? There, unfortunately, is not. Now, we can't just immediately jump to the 18 and say, okay, what are the factors of 18 that combine to give me 15? The reason you can't is because this leading coefficient is greater than 1. Okay, so see right here, all my leading coefficients were 1. Well, right here, it was 1 after I factored. So I didn't have to do that. But here I do. So here's what you're going to do. Remember, this is called the AC method. So you have to take the first number, 2, and multiply it by the last number, 18. So 2 times 18, this is going to give me 36. Think of this as your C now, like your constant. I am looking at factors of 36 that I can combine now and get 15. So let's look at 1 and 36. Can I combine these in any way to create 15? Ooh, not really. Okay, let's go to the next one. What about 2 and 18? Can I combine these in any way and get 15? No, you can't. All right, what about 3 and 12? Can I combine these in any way to get 15? Yes, I can. Now, think about this. I need to multiply these two numbers together and get positive 36. I need to combine these two and get negative 15. So how am I going to multiply them together and get a positive number, but when I combine them, get a negative number? And that is both of these have to be negative, because a negative and a negative give you a positive. Now, when the leading coefficient is not equal to 1, we're going to write out 4 terms. Because in Algebra 1, with 4 terms, you learned about a thing called factor by grouping. So watch this. I am now going to say 2x squared minus 3x minus 12x plus 18. Now you say, why did we do that? What are we doing here? Look at what I did. All I'm doing is expanding this trinomial, 3 terms, into a polynomial, 4 terms. 1, 2, 3, 4. Now, I didn't change the value. Look right here, negative 15. What's negative 3 minus 12? Oh, look, negative 15. I didn't change it at all. But by making it 4 terms, look at what I can do here now. I can combine the first 2 and the last 2, and I can do factor by grouping. So right here, what's the greatest common factor? Looks like x. So now I have 2x minus 3. Now, I should be able to factor something out of this binomial and make it look just like this one. So the x, or the coefficient in front of the x, has to be positive, so I'm going to have to factor out some negative value. What about negative 6? That gives me 2x minus 3. How'd you get the negative 3? What's 18 divided by negative 6? Remember, factoring is synonymous with division. It means divide. Factoring means divide. That is the definition. All right? So now I can factor out the 2x minus 3. So here what I have is 2x minus 3. And what am I left with? I am left with x minus 6. And here are my factors. If I multiply these together, I will get this. Now, that's really all you're doing is you're adding that extra step of saying a times c. I want you to pause the video. I want you to try these two, and then unpause the video and watch what I do and make sure you got the same thing. You are going to see these so many times throughout this unit. This is something we must be good at. All right, so here we go. We have 6 and we have 21. Unfortunately, nothing can be factored out. There is no number that goes into 6, 5, and 21. So we got a big number to multiply with. So 6 times 20 is 120, and 6 times 1 is 6. So 120 and 6 give me 126. Now, I did 6 times negative 21, so that's negative 126. Now, I'm looking at factors of this that I can combine and give me 5. Oh, goodness. We got a ways to go. All right, so I'm going to write teeny tiny, or I may have to erase. So we got 2, and we got, what do we got after 2? 63. All right, clearly that's not going to work. All right, what else do we have? 3, and that gives me 42. That's not going to work. 4, and that gives me 32. That ain't going to work. 5 doesn't go in there. What about 6? 6, that gives me 21. No, that won't give me 5. What about 7? Can 7 go into 126? Can I say 126 divided by 7? 18. 7 and 18. That doesn't work. What about 8? 126 divided by 8. Would that work? Nope. What about 126 divided by 9? Would that work? 14 and 9. So 9 and 14. Can that combine and give me 5? And yes, it can. Now, looking at this. So here, we have to combine 9 and 14 to get negative 5. So remember, I have to multiply these together to get negative 126. Let me go ahead and erase this so that I can have a little bit of room to work here. So we know it's 9 and 14. Let's go ahead and erase all this. All right, 9 and 14. One of these has to be negative, because a positive times a negative is how we get this negative right here. So one of them has to be negative, and when I combine them, I get negative 5. All right? So here, my 9 should be positive, and my 14 should be negative, because 9 minus 14 gives me the negative 5. So now these are going to be my middle numbers. So what I have now is 6y squared plus 9y minus 14y minus 21. So remember, I have not changed the value of what's in blue. 9 minus 14 is 5, negative 5. So I'm still working with the same thing. What is convenient about this method is now I can do factor by grouping. So the GCF here looks like it's going to be 3y. So that is going to leave me with 2y plus 3. And then here I can factor out negative 7. And that leaves me with 2y plus 3. The greatest common factor here is 2y plus 3. So I can factor that out. So I get 2y plus 3. And I am left with 3y minus 7. And there we have it. Those are my factors. All right, last one. 9, 4, this is 36. All right, what factors of 36 can I combine and give me 12? What about 6 and 6? 6 times 6 is 36, and then 6 minus 6 right here, that will give me the negative 12. So now what we have is 9x squared minus 6x minus 6x plus 4. Now I can do my factor by grouping. So I'm going to pair these together. Here I can factor out a 3x. And I'm left with 3x minus 2. Here I can factor out a negative 2. And I'm left with 3x minus 2. Running out of room. So now I'm left with 3x minus 2 times 3x minus 2. And remember, anytime your binomials are the exact same, you are going to want to get in the habit of rewriting. So you have 3x minus 2. This is quantity squared. All right. And there is one final way to solve a quadratic when you're thinking about factoring, and that is difference of squares. So remember that rule. If I have a squared minus b squared, this is equal to a plus b and a minus b. So really what you're doing is you're looking at the square root of a and the square root of b. You're writing it out just like this. One is plus, one is minus. So what's the square root of x squared? X. What's the square root of 4? 2. So I can write it like this. X plus 2, x minus 2. And that's it. Right here, what's the square root of 9x squared? Well, let's think about that. What's the square root of 9x squared? All right, well, this is the same thing as the square root of 9 and the square root of x squared. Square root of 9 is 3, square root of x squared, x. So this is that. And then this is the square root of 25, y to the 4th. Remember, the number 25 times the variable, y to the 4th. So that is 5. Here, remember, you're just dividing that by 2. So this is going to be y squared. So this is going to be 3x plus 5y squared and 3x minus 5y squared. And then, same thing here, 72 and 2. Mr. Phillips, these are not perfect squares. Remember what step always is? What is that? What is step always? You cannot forget it. Greatest common factor. So let's factor out a 2, and then I get 36r to the 6th minus s squared. All right. Now, can I take the square root of this? Yes, you can. What's the square root of 36? 6. What's the square root of r to the 6th? Divide it by 3. r 3. And this will be or you can just say plus s, and then 6r3 minus s. And there you have it. So that is a quick refresher on solving quadratics by hand. I can graph, I can greatest common factor. Greatest common factor, don't ever forget it. It is easy to forget. It is step always. Always, always, always. Check for the greatest common factor. We can do basic factoring when a is 1. Don't forget about the AC method. This is going to show up a lot. And then you have your difference of squares. All right, that's going to be all for this video. I hope you enjoyed the quick refresher for solving quadratics by hand. If you have any questions, please leave them in the comments, and we'll see you all in the next video.